Ready?
God, I really hope.
All right, perfect.
Action.
All right, here we go. So example 1, or problem 1, says to evaluate this plus this. The dimensions have to match. Hint, the dimensions will match. I'm not going to give you a problem on the test you can't do. So, don't worry about the matching dimensions thing. It should work. What I want to focus on is what am I supposed to do, which is addition. I want to add each element on the same position. So first row, first column by first row, first column, first row, second by first row, second, and so on. So I'm going to get 6 total sums here. 3 plus 2 is 5. 3 plus 5 is 8. Sorry, I already messed up. Negative 1 plus 5 is 4. 4 plus negative 3 is 1. 0 plus 9 is 9. 2 plus 1 is 3. 7 plus negative 5 is 2. Okay. And I demonstrated very clearly how we can mess up on a problem like that by going too fast through it. So be careful that each element that you're multiplying is, or that you're adding is the proper element. So this one's getting added to that one, this one's getting added to that one, and so on and so forth. Okay, so that shouldn't take anybody more than about 30 seconds to do. If you give yourself a minute to make sure you don't mess up, then you'll probably get a correct answer on that one. You have 45 minutes to do 10 problems. You should have a minute to spare on that problem. Number 2, same difficulty level. The only difference is we have some scalar multiples here by the matrices. So 3 is being multiplied by matrix B. This being subtracted by 2 by matrix A. So the first thing I'm going to do is write the problem out as it should be written. So 3B means 3 times matrix B. 3 times 5, 3, 2, 5, 3. 2, negative 7. It says minus 2A, so minus 2 times A, which is 2 times 2, negative 4, 1, 8. Now option A, I can multiply the negative 2 times all the numbers in the second thing, so all the signs have been negated, but then it becomes a plus problem where I can just subtract 2 times each thing. Take your pick on that. 3 times all this is pretty obvious. So I'm going to do 3 times 5 is 15, 3 times 3 is 9, 3 times 2 is 6, 3 times negative 7 is negative 21. For me personally, I'd keep the minus sign here and not worry about that in this step. I'm going to multiply 2 times all these numbers here. 2 times 2 is 4, 2 times negative 4 is negative 8, 2 times 1 is 2, 2 times 8 is 16. And now it's the subtraction of matrices problem. So I'm going to have subtraction, so 15 minus 4 in the top left corner is going to be positive 11. 9 minus negative 8, so minus negative means plus. 9 plus 8 is 17. 6 minus 2 is 4. And negative 21 minus 16 is negative 37. All right. So that's the first 2 problems. Should be 12 easy points right there for everybody. Main thing there, be careful. That's where people mess up on those. They add when they're supposed to subtract. They maybe multiply by negative 2, but then they change it to a multiplication problem instead of an addition or subtraction problem, that kind of stuff. So just be careful with those 2. Number 3, I did make an error in my problem here. It says column 1, it should say row 1 represents genes. It says column 2, it should say row 2. I'll fix that on the test. So it does say rows. So we have a following matrix represents the cost of clothing at Cool Threads. The columns represent the brands of Vintage, Casual, and Distressed. So row 1, row 2, row 3 represent those types of things. And then row 1 represents jeans. So row 1 is this one. This is jeans. And row 2 represents jackets. This is jackets. Okay. The problem states, if the sales tax rate is 7%, what is the sales tax on a pair of casual jeans? So I'm not asking you to do a whole bunch of stuff with this. I basically want to know that you can interpret this matrix properly. Casual jeans would be in the jeans row, the casual column. That represents $210 is how much those jeans cost. Must be expensive jeans, I don't know. $210. Okay. Well, my jeans cost like 25 bucks, so that's.
It's rich people.
Yeah, it must be. Yeah, it must be.
Must
Be one of these stores you walk into and you're like, I probably don't belong in this store. And I'll probably go someplace else. But anyway, but casual jeans at this particular store, $210. They want to know the sales tax on those jeans. The sales tax rate is 7%, so I'm simply going to multiply the cost of the pair of jeans times the sales tax rate as a decimal. Be careful, single digit percent, you got to move 2 places, so it's 0.07, not 0.7. 0.07. And if you type that in a calculator, I got $14.70 earlier when I did it, so I believe it's still the same answer. So the sales tax on this pair of jeans would be $14.70. That's what they're asking for. So that's the answer.
Do they want us to put dollars?
Well, it's money, so I would put dollars in, put units on your answer. Yeah. So there's no dollars, so what I was getting here, there's no dollars in the matrix, which is fine. But since it does represent money, it'd be good to put a dollar symbol. If you didn't put the dollar symbol, I wouldn't count it wrong, but it's just good math to put that dollar symbol on there to represent money. Okay. Everybody comfortable with number 3?
Yeah.
It probably might be a different store, might be different prices. The only thing I could do beyond that would be say, what would give me a matrix that gives me the sales tax of all these. So 0.07 times everything and just give me a matrix in the same setup. I might do something like that, but that'd be the most challenging thing I do there. Everybody comfortable? All right. Numbers 4 and 5. Okay. This is where, as a class, some of you started going off the rails with this whole matrix arithmetic stuff. Multiplication of matrices. I'm going to use some highlighting on this one to help you see where things are coming from, and hopefully that'll help. The first thing to remember is to be able to do matrix multiplication, the dimensions of this is 2 rows by 2 columns. 2 rows by 2 columns. And the dimensions of this are 2 rows by 2 columns. In order to be able to multiply matrices together, these numbers have to be the same number. That means it's possible to do it. And these represent the dimensions of your answer, 2 by 2. Right? So the fact these numbers match means I can do it, and since they do match, this number of rows, this number of columns end up in my final answer. So with that in mind, the way we do the matrix multiplication is we multiply the row, top row of the first matrix times the first column of the second matrix. So we're doing this times that. And when I create my answer matrix, it's going to create the first row, first column is going to create the first row, first column answer here. So I'm going to take the very first number in my row times the very first number in my column, plus the second number in my row times the second number in my column. Okay, it's just a sum of the products, so first times first, second times second. Then I'm going to multiply the same row times the next column to get this answer. So I've got first times first, that's 3 times -2, plus second times second, that's 6 times 2. Then I multiply the second row times the first column to get this second row, first column answer. I'm going to take the first number 0 times the first number 4 plus the second number -3 times the second number 5. First times first plus second times second. And finally, to get the last one, I'm going to multiply the second row times the second column to get the second row, second column answer. First 0 times first -2 plus second -3 times second +2. All right. Multiply then add. So 3 times 4 is 12, 6 times 5 is 30, 12 plus 30 makes 42. That's my top left. 3 times -2 is -6, 6 times 2 is +12, -6 plus 12 is +6. 0 times 4 is 0, -3 times 5, that makes -15. 0 minus 15 is -15. 0 times -2 is 0, and -3 times 2 is -6. That makes -6. The end. Okay. A few of you on your homework, you got all the way to this point, and then you went one more step and said 48 -21. You added them up to make one simple matrix like that. Don't do that. All right. So again, once you get your 2 by 2 matrix, that's when you're done multiplying. That's when you stop. Okay. some of you are having issues with what to multiply against what, others were having issues with when you're done. So those are the types of mistakes you're making, so be careful that you go as far as you're supposed to go and do it correctly to that point. Any concerns on that one before I move on to number 5? Okay. Number 5, we have a distributive property here, and we have option A is to multiply A times B and A times C and then add them together. We'll call that the bad option. Option B, we add these together first, then multiply the sum times the matrix A. Remember with matrix multiplication, the order of multiplication does matter, so make sure you don't modify the order of things. So first off, I'm going to focus on B plus C. B plus C tells me to take a look at matrix B and matrix C and add them together. It's basically the equivalent of problem number 1 on the test. So, if I'm writing down B plus C here, it's just going to be first times first, second times second, third times third, fourth, or plus. First plus first, second plus second, right? So negative 2 plus 3 is positive 1. Positive 4 plus negative 2 is positive 2. 3 plus 5 is positive 8. 1 plus 2 is positive 3. So you do your B plus C. Now, this tells me to multiply A times B plus C, and again, order matters. A times B plus C. So A is 2, 7, 4, 3 times B plus C, which is 1, 2, 8, 3. If you put it in opposite order, you get a different answer. That's the wrong answer. So be careful. A first times B plus C second. And now it's just what we did over here. Row times column, row times column, row times column, row times column. So it's going to be 2, 7 times 1, 8. That's going to be 2 times 1 plus 7 times 8. Then it's going to be 2, 7, oh shoot. It's all coming back. All right, so now it's going to be, there we go, 2, 7 times 2, 3. So 2 times 2 is 4, plus 7 times 3, 21. Then it's going to be 4, 3, and 1, 8. So 4 times 1 plus 3 times 8, and then it's 4, 3, and 2, 3. So it's 4 times 2 plus 3 times 3. So my end result here is going to be, that's 2 plus 56, which is 58. This is 4 plus 21, which is 25. This is 4 plus 24, which is 28. And this is 8 plus 9, which is 17. And again, stop. Once you get to that answer, once you multiplied and did all your stuff, the end, there's nothing else to do. Okay. Any concerns on matrix multiplication? We're all comfortable with that? Number 6. Math teacher assigns final grades based on a weighted system. Matrix W represents the weights of each type of assignment. We have homework and tests weighted at 30% and 70%. And matrix G is the grade matrix for the 2 students, John and Kathy. John got 75 homework average, 68 test average. Kathy got a 92 homework average, 95 test average. I want you to guys notice about John. Kind of lazy on his homework, and he ends up with a low test score, even lower than his homework grade. Kathy's working hard on her homework, it's a 92%. Misses some occasionally, but then her test scores are up because she's a hard worker. So that's the moral of John and Kathy. Work harder, do better. So use matrix multiplication to find matrix F that represents the final class grades for these 2 students. So I have a 1 by 2 matrix being multiplied by a 2 by 2 matrix, which means 2 matches 2, it's possible to do it. I'm going to get a 1 row by 2 column matrix for my answer. So my answer should look like this, just with different numbers in it. All right. So specifically what I'm doing here is 0.30, 0.70 times 75, 92, 68, 95. And again, I'm going to take a row times a column. So, for John and Kathy, John's going to be this row times the John column, so 0.30 times 75 plus 0.70 times 68. Kathy is going to be 0.30 times 92 plus 0.70 times 95. So if we take 0.30 times 75 plus 0.70 times 68, that gets us a grade of, just squeaked by for John. So John ended up with a 70.1 average. Probably thrilled to death that he passed the class. Praying to God he doesn't have to take class next year. Plus 0.70 times 95, that's Kathy's setup, and she ends up with a 94.1 A, solid A for Kathy, hard worker that she is. So it's good for her. So that's my matrix F. Final grades.
Does it matter which way you put it?
It should be this way, not that way,
You
just
want
based
us
on your
to
matrix
write the
multiplication.
answer like that?
I want you to write the answer as a matrix, yes. And again, remember that if I multiply a 1 by 2 by a 2 by 2, I should get 1 row and 2 columns, which looks like that. So if you give me a vertical matrix instead of a horizontal matrix, you won't get full credit because you did your multiplication improperly, even if you have the right numbers in it. All right? On the test, I'm going to have John and Kathy. Maybe she does more than him this time. I don't know. Maybe he starts becoming a harder worker. The weights might be differently assessed, whatever, but it'll be a similar setup. All right, numbers 7 and 8. Okay, first off, there's different ways to write vectors. There's the component form. There's the polar / trigonometric form. The polar trigonometric form gives magnitude and direction. So the ways of asking those questions, if it says magnitude and direction, it wants the trigonometric form. If it says write the trigonometric form, it wants the trigonometric form. If it says write the component form, it wants the form looking like that. So looking at these answers, when I was checking what you guys did, I saw some of you had the right answers in the right form, some of you had the right answers in the wrong form. So be careful that you know what form each one is that you're supposed to do. All right, maybe make note of that on your index card that you're going to make for the test. So, if I know the initial and terminal point of a vector, and I want to find the magnitude and direction of the vector, I want to find the x and y components of my vector. To find the x component, I simply do the x terminal minus the x initial. So the terminal x, -1, minus the initial x, 5, gives me -6 as the component for x. And my terminal y, 14, minus my terminal, or my initial y, 10, gives me 4 for y. So the component form of this vector is -6, 4. Okay, that's the first thing I want to do is I want component form to be able to create the trigonometric form. How much more time do I have? 52, so I got 15 minutes. All right, so once I get the component form down, now it's just a matter of changing this over to polar form. And the 3 steps to make of the trigonometric form, the 3 steps is step 1. The magnitude is going to be the square root of the squares of these two numbers, so 6 squared plus 4 squared. In step 1, negative signs do not happen. Everything's getting squared, everything's positive when you square things. So if I type in my calculator, the square root of 6 squared plus 4 squared, my calculator automatically puts the parentheses, yours doesn't, right? So square root, put the parentheses, 6 squared plus 4 squared in parentheses equals, that's 7.21. Step 2 in the process of going to the trigonometric form here, I'm going to do the inverse tangent. Alpha equals the inverse tangent of the second number over the first number. The official rule has absolute value bars around that fraction, so negative signs don't count. If you don't put the negative signs down, don't worry about the absolute value bars. Again, on your calculator, I'm going to hit the inverse tangent button. My calculator puts a parentheses, yours does not. Make sure you put a parentheses there. Inverse tangent of 4 divided by 6 and parentheses is 33.69 degrees. Okay. If you happen to get an answer around 1, like somewhere between 0 and 1.5 even, you're probably in radians instead of degrees. You might want to fix your calculator mode. The angle should be something much larger than 1. All right? I'm not going to give you some weird vector that has like a 1 degree angle on it. So you're probably in radians instead of degrees. Make sure you fix your calculator mode. Finally, quadrant. Once I get component form, which is this, the numbers establish the horizontal and vertical directions. The horizontal, the first number is negative, which takes me left. The second number is the vertical, takes me up, negative, positive. So I go left and up. That puts me in the second quadrant. In the second quadrant, my rule for theta is equal to 180 minus alpha. So in this case, theta is going to equal 180 minus 33.69 degrees, which is 146.31 degrees. So the magnitude of the direction of the vector are 7.21 at an angle of 146.31 degrees. That's what I'm looking for that problem. Problem 8. I put 8 and 9 on here to give you guys an easy 12 points. You're welcome. All right, so there's a lot of easy 6 points on these. So again, the easy ones, make sure you get them right. The more challenging ones, get the easy ones right first, and then maybe budget your time. I've got 35 minutes left. I've got 5 problems to do. That's 7 minutes per problem. Then you have plenty of time to work through them, right? So, vector 1 minus vector 2, they're both in component form. I simply take x component minus x component. So the x component of my answer is going to be 9 minus negative 5, which is 14. Then I've got y component minus y component. So the y component is going to be 7 minus 3, which equals positive 4. And once the answer in component form, so 14 comma 4 in component form, the end. All right? That's all number 8 is going to be. I might add instead of subtract, but it's going to be 2 vectors in component form with some simple operation of addition or subtraction. All right? Number 9. I didn't actually teach you scalar multiplication of a vector. I figured it wouldn't be too hard to understand it just by the study guide. It's just like scalar multiplication of a matrix. I'm going to multiply 3 times both of these numbers. So that one's going to become 12 comma 6. Then there's a plus sign, so I'm going to write plus. And then I've got 2 times this. So it's going to be negative 6 comma 10. All right. Now it's an addition of 2 vectors. So now I'm just going to add the 2 vectors up. 12 minus 6 is 6. 6 plus 10 is 16. 12 plus negative 6, that's why I subtracted. 6 plus positive, and that's why I added. That is the component form answer. It asks for the answer in trigonometric form, so now I'm going to go through that 3-step process again. Step 1, find r. Step 2, find alpha. Step 3, find theta. So, step 1, r equals the square root of 6 squared plus 16 squared. In my calculator it says that equals 17.09. Step 2, alpha equals inverse tangent of the second divided by the first, that's 16 over 6. Inverse tangent, 16 divided by 6 is 69.44 degrees. And finally, my component is positive, which takes me right, and positive, which takes me up. If I'm going right and up, I end up in the first quadrant. In the first quadrant, theta equals alpha. So, step 3, theta equals alpha. So my answer is 17.09 at an angle of 69.44 degrees. Maybe you make note on your index card what type of form the answers are in for the problems. If you're not 100% certain about the terminology, make sure number 7 looks like this, make sure number 9 looks like this with the number angle thing. Right?
Change it to 17.1.
Well, did I count that right? I'd like a couple decimal places instead of 1, unless it specifically says round up to 10 nearest town. But I wouldn't count 7.1 wrong. Just don't get too crazy with your rounding. Makes some of the math work out as you get into bigger, better classes. Start rounding in the beginning of the problem, it gets the answers way off at the end. All right, finally, we got Yumiko operating a boat across river with engine speed set at 14 miles per hour and a bearing of south 30 degrees west. I'm going to take a picture of this here, and we're going to draw what that looks like. So, Yumiko's boat vector starts here, and she's going south 30 degrees west. So the first direction tells you where to look, and the second direction tells you which way to go off of that. So we're going 30 degrees west of south. So 30 degrees is going this way, and her vector is 14 miles per hour. Everybody okay with Yumiko's boat speed vector? All right. The current of the river is 4 miles per hour and a bearing of north 20 degrees east. So if I were to start the current vector here, we're looking north to start off with, and 20 degrees east of north, which would be going north is this way, east is that way. So we're going to go 20 degrees off the north line, about like this, and it's 4 miles per hour, so let's make it shorter. This is 4 miles per hour at a 20-degree angle east of north. So the blue vector represents her boat speed vector, the red vector represents the current speed vector. You can see she's sailing somewhat into the current, so we should expect her to be slowing down because her boat wants to go 14 miles per hour, the current's pushing her slower. And her end result, her resultant vector here, is going to be some magnitude, some direction. And I want a direction similar in nature to the directions they're giving me, north or south, east and west, right? So I'm looking at this, and if I'm considering, here is my original picture, she is south some number of degrees west of that, right? So I'm really looking for the magnitude of this, we'll call this R for a magnitude, and I'm looking for this angle right here, I'm going to call it beta. That's what I'm looking for. The speed of her boat is R, and the angle that she is west of south is going to be beta. First thing I want to do is I want to construct a vector addition problem to represent the problem situation. So, I need to consider a coordinate axis at each point for both the boat and the current. And I want to figure out what theta is for each of those vectors. So what's theta for that one, first of all? So the first vector, the blue vector, is a 14 mile per hour vector. That's the magnitude. I want an angle theta to deal with it the way we've been dealing with it. So, using just common sense in 90, 180, 270, 360, can everybody see that if I went all the way around to here, it's 270, we're stopping 30 degrees short of 270, so it'd be 240. So 14 at an angle of 240 degrees is the representation of her boat vector using polar coordinates that we're used to working with. And if we look at the current vector, here's my coordinate axis here. And I'm looking at this vector, that's what I'm looking for, theta. I'm adding a 4 mile per hour vector at an angle of what? 70, right? So, because again, that's 90 degrees, we're stopping 20 degrees short of 90, so that's 70 degrees. Okay, so I want to write a vector addition problem using normal polar form that we have been using here. Next, I want to change this to component form. Your x component is going to be 14 cosine of 240. Your y component is going to be 14 sine of 240. And for this one, your components are going to be 4 cosine of 70, and your y component is going to be 4 sine of 70. So we grab our calculator, we punch those in and see what we get. So 14 cosine of 240, mine shows all at the same time, so I'm just doing them all at the same time. 14 sine of 240, you guys can obviously record yours as you find them. 4 cosine of 70 and 4 sine of 70. So I get negative 7 for this one, I get negative 12.12 for this one, I get 1.37 for this one, and I get 3.76 for this one. So my vector addition in polar form becomes, in component form, -7 comma -12.12 plus 1.37, 3.76. Then it's just vector addition like we know how to do it. So -7 plus 1.37 is -5.63. And -12.12 plus 3.76 is -8.36. Okay, so all that work gets us the component form of the answer. Her boat vector speed is horizontally 5.63 left, 8.36 down. We want to now find a magnitude and a direction to associate with that. So, step one is what it has been. R equals the square root of 5.63 squared plus 8.36 squared. So square root of 5.63 squared plus 8.36 squared. That comes out to 10.08. That's how fast she's going. Alpha is going to be this. Remember, alpha is dependent on what quadrant you're in. If I'm in the second quadrant, I go down to the x-axis. Third quadrant, up to the x-axis. First quadrant, down to the x-axis. Fourth quadrant, up to the x-axis. So I'm in the third quadrant, so I'm going up to the x-axis. That's alpha. Alpha equals inverse tangent of 8.36 over 5.63. So inverse tangent, again, use parentheses, inverse tangent parentheses, 8.36 divided by 5.63, that's 56.04 degrees. And finally, alpha plus beta is equal to 90 by the picture. So if I put 56.04 here, I subtract it, I get 33.96 degrees is beta. So my answer is 10.08 miles per hour, 10.08 miles per hour. And the direction is south 33.96 west. So south 33.96 degrees west. And that's how you do it. Good luck on your test on Monday.
I get a note card.